My hand is wedged in a crevice up to the elbow, my regulator is fogging up, and the rock I've been trying to grab for the last 40 seconds just winked at me. Not blinked, winked. One eye, slow, deliberate, unmistakably smug. The rock was never a rock. It had been sitting there the whole time pretending to be geology, watching a grown man in a wetsuit argue with the ocean floor. And the second I finally believed it, the second my brain relaxed and said, okay, that's definitely just a rock, it turned the color of the sand around it, flared out like a bedsheet in the wind, and vanished into a hole roughly the size of a coffee cup. My arm did not fit through a coffee cup-sized hole. My arm found that out the hard way, at depth, with my air running low and my heart rate doing something my dive instructor specifically warned me never to let it do. Yep, that's me. You're probably wondering how I ended up here. Oh, hey there. I should clarify, here is a complicated word for someone in my situation. I don't have a body anymore. I have vibes, a very specific, unfinished business involving cephalopods, and what appears to be unlimited free time to hang around reefs, kelp forests, and touch tanks, watching the same eight-armed troublemakers do the same impossible things over and over, forever. I used to be a guy who loved the ocean a completely normal, healthy amount. Then I met an octopus, got a little too confident, got my arm stuck reaching for something that was actively trying not to be reached, panicked exactly as much as you'd expect, and that was that. Rookie mistake, ironic mistake, the kind of mistake that becomes a permanent hobby once you're dead and have nothing but time. So now I watch octopuses, all of them, all the time, because it turns out the moment right before something eats an octopus or fails spectacularly to eat an octopus is one of the strangest, funniest, most quietly genius spectacles nature has ever produced, and nobody tells you about 90% of it. Documentaries show you the color change and move on like that's the whole trick. The color change is the appetizer. Let's get into it. Here's the thing everyone gets wrong immediately. People think an octopus changes color the way a mood ring changes color, slowly, gently, like it's thinking about it. It is not thinking about it. It is reacting faster than your eye can process. An octopus's skin is packed with tens of thousands of tiny organs called chromatophores, sacs of pigment surrounded by muscles that can expand or contract in a fraction of a second. We're talking under 200 milliseconds. For comparison, the average human blink takes about 100 milliseconds longer than that. You could blink and miss the entire disguise. But color is layer 1. Underneath the chromatophores sit reflective cells called iridophores and leucophores, which bounce and scatter light to fake texture, shine, even the illusion of depth. And on top of all of that, the skin itself can physically pucker into bumps called papillae, turning smooth skin into something that looks exactly like coral or algae or barnacle-crusted rock in under a second. So when a predator is scanning the reef, it's not looking at an octopus that changed color. It's looking at a living special effects team running 3 separate departments, pigment, light, and texture, simultaneously with zero rehearsal live under mortal pressure. Evolution looked at just be gray and said, no, we're doing all 3. Here's where it gets properly unsettling, and I mean that as the highest compliment. Researchers studying octopus skin found something that sounds made up. The skin itself contains light-sensitive proteins called opsins, the same family of molecules your eyes use to detect light. This means an octopus's skin may be able to sense light and shadow directly, independent of its actual eyes, and trigger a camouflage response locally without waiting for a signal from the brain. Think about what that means practically. A predator's shadow falls across one patch of skin on the far side of the octopus's body, a patch the eyes aren't even looking at, and that patch may start adjusting itself before the message has even finished traveling to headquarters. It's less "I see danger, therefore I hide," and more "my own left arm noticed danger and started hiding without asking permission." Your skin does not have opinions. An octopus's apparently does, and its opinion is always "not today." Fast fact 1. Octopus blood is blue. Everyone knows that part. What people skip is why it's relevant to a predator encounter at all. Human blood uses iron-based hemoglobin to carry oxygen. Octopus blood uses copper-based hemocyanin instead, which is significantly less efficient at room temperature, but far better at transporting oxygen in cold, low-oxygen water. Combine that with 3 hearts, 2 of which exist purely to pump blood through the gills, and you've got an animal built specifically to survive extended bursts of panic-level exertion in conditions that would leave most animals gasping. Translation: when an octopus needs to jet away from something with teeth, its entire circulatory system was custom-built for exactly that emergency in exactly that water temperature. You panic and your face goes red. An octopus panics and its whole body is already prepared for the marathon. Scenario 1. You're the diver. Not me, you this time, since I already learned this lesson the expensive way. You're 30 feet down, following a trail of shell fragments and crab claws along the sand, a midden, the leftover trash pile outside an octopus den, and you spot the entrance. Dark, small, promising. You reach in slowly, your fingers brush something soft, cool, and immediately not there anymore. A puff of sediment blooms up around your hand, like someone just slammed a door made of dust. Here's what actually happened to that half second. The octopus detected pressure change or shadow, fired its chromatophores to flash pale as a startle signal to itself and any nearby octopus watchers, contracted its mantle, forced water through its siphon like a tiny cannon, and shot itself backward through an opening you couldn't fit 2 fingers through, while simultaneously kicking up sand to cover the exit. You got a face full of silt and a story. It got its Tuesday back. Everybody knows octopus is ink. Almost nobody knows what the ink is actually doing chemically once it's in the water. The ink itself is mostly melanin, the same pigment in your skin and hair, mixed with mucus that thickens it into a cloud. But here's the part documentaries usually skip. That cloud is frequently shaped and released in a way that mimics the octopus's own body outline, a pseudomorph. A predator lunges at the cloud, the real octopus jets off in the opposite direction, and for one crucial second, the attacker is biting a shape of mucus and disappointment. There's more. Research on ink from species like the California two-spot octopus suggests it can contain compounds that interfere with a predator's sense of smell and taste, essentially jamming the predator's sensory equipment mid-chase. It's not a smokescreen. It's a smokescreen that also slops a "Do Not Disturb" sign directly onto the attacker's nose. Myth 1. True or false? Myth. Octopus ink is basically squid ink, and it's just there to hide the octopus. Full stop. Verdict: false, or at minimum, dramatically incomplete. Why it's false? The pseudomorph decoy shape and the sensory jamming chemistry mean the ink isn't a curtain, it's an active countermeasure, part fake body double, part chemical warfare. You wouldn't call a smoke grenade just smoke if it also temporarily blinded and deafened the person chasing you. Same principle. Nature just did it first and did it better and never patented anything. This is the fact that made me, personally, deeply uncomfortable while I was alive, and I say that with love. An octopus has roughly 500 million neurons, comparable to a dog, but only about a third of them live in the central brain. The rest are distributed through the arms themselves in a dense network of nerve clusters running down each limb. Each arm can process sensory information and generate reflexive movement largely on its own, without waiting for instructions from the brain. Which means when a predator clamps down on one arm, that arm can begin reacting to the threat before the octopus, as a whole conscious animal, has even fully registered what's happening. It's a bit like your foot deciding independently to kick a spider off your leg while your brain is 3 seconds behind going, "Wait, was that a spider?" And in some species, that same distributed system supports autotomy, a form of self-amputation where an arm caught by a predator can detach at a preset point, buying the rest of the octopus precious seconds to escape. The severed arm keeps twitching and grabbing on its own for a while afterwards, which is either the most metal defense mechanism in the ocean or a horror movie prop, depending entirely on your mood that day. Given that it later regrows, I'm going to go with metal. What is actually going through its head? Let's be honest about what we know versus what we're guessing here, because I promised you clinical honesty and I intend to deliver it, ghost or no ghost. We know octopuses release stress hormones, catecholamines, similar in function to human adrenaline when facing a threat, spiking heart rate and priming the body for a burst of exertion. That part is documented. What's likely, based on behavior, is that an octopus facing a predator is running a rapid cost-benefit calculation: flee, hide, ink, bluff, or fight, weighted by how much energy it has left, how close the den is, and what worked last time. Octopuses have demonstrated the capacity to learn from individual past encounters, which suggests this isn't pure blind reflex. What's hypothesized and still debated is how much of this involves anything resembling a subjective experience of fear the way we'd define it. Scientists are cautious here, and so am I. The honest answer is, we know the hardware for panic exists. We don't fully know what it feels like to be the one panicking, which incidentally is also true of most of my ex-coworkers. Which brings us to something even stranger than distributed nervous systems, because apparently the ocean wasn't done showing off. The mimic octopus, found mainly in the muddy waters off Indonesia, doesn't just blend into its surroundings, it impersonates other animals, actively, on purpose. Researchers have documented it flattening its body and undulating along the seafloor in a closely resembling poisonous flatfish. They've documented it tucking 6 arms into a burrow and waving the remaining 2 in opposite directions, banded and rippling, mimicking a venomous sea snake. It has also been observed spreading its arms and adopting the spiky silhouette associated with lionfish. Think about the audition process required here. This is an animal with no vocal cords, no script, no rehearsal footage of the animals it's copying, somehow producing a possible physical impression of at least 3 different dangerous species, selected, as far as researchers can tell, based on which predators happen to be nearby at the time. It's less camouflage and more immediate improv theater, life or death stakes, no notes. I've watched a lot of species try to bluff their way out of danger. Nothing else on this reef has range like that. Fast fact 2. Remember those papillae from part 1, the skin bumps that fake texture? Some species can shift from smooth skin to jagged coral-like ridges and back to smooth again in under a second, repeatedly, without apparent effort. Try clenching and unclenching every muscle in your face that fast for that long without getting a headache. You need a nap. It needs nothing. It just does it again in 10 minutes because a fish looked at it funny. Scenario 2. You're a moray eel this time. Stick with me. Morays are one of the octopus's primary predators, specifically because they can do the one thing octopuses rely on dens to prevent: fit into tight crevices and root around inside them. An octopus hiding in a hole isn't automatically safe from a moray the way it would be from a barracuda. So you, the eel, slide into a crock in the reef, nose first, scenting for anything hiding in the dark. And there, pressed into the back corner, is exactly what you're looking for. Except it's already gone pale, already flattened itself against the rock in a shape that barely reads as an animal anymore, already prepared a jet of water aimed directly at the gap you just entered through. The moment you commit to the strike, the water blast hits you in the face with a spray of sand, and by the time your vision clears, the prey has squeezed itself out the side gap you didn't even register as an opening. You got a mouthful of grit. It got to keep being alive. This particular rivalry has apparently been running for millions of years, and near as I can tell, neither side is planning to concede. Myth 2. True or false? Myth. Octopuses are shy, passive little creatures that only ever run and hide. Verdict, false, and honestly a little insulting to them. Why it's false? Alongside all the fleeing and hiding, octopuses have been documented using diamatic displays, sudden, aggressive-looking bluffs meant to startle a predator into hesitating. This can involve flaring the body larger, flashing bold eye spot patterns, rearing up with arms spread wide, and shifting instantly from camouflaged and invisible to loud, high contrast, and unmissable. It's the visual equivalent of someone jumping out behind a couch yelling, "Except the couch was also invisible a second ago." Shy is not the word. Strategic is the word. The veined octopus, sometimes nicknamed the coconut octopus, has been observed collecting coconut shell halves and clamshells, carrying them stacked together while walking awkwardly across the seafloor on its arms, and then assembling them into a makeshift armored shelter when a predator approaches. This matters more than it sounds like it should, because carrying that shell around is not free. It's clumsy, it's slow, it uses energy the octopus could otherwise spend hunting or fleeing normally. The trade-off only makes sense if the future protection is worth more than the present inconvenience, which means this behavior requires something very close to planning for a threat that hasn't happened yet, not reacting to a predator, preparing for one. This is less instinct and more tiny caffeinated accountant managing a very specific risk portfolio. Somewhere out there is an octopus that looked at the concept of home insurance and invented it out of garbage, using no hands because it doesn't have any. Let's put some real numbers on all of this because I promised no naked statistics. Field studies on octopus hatchlings suggest survival rates from egg to adulthood are extremely low. Commonly cited estimates put it in the range of 1 or 2 survivors out of every 100,000 eggs a female produces, depending on species. To put that in perspective, that's a worse survival rate than winning specific hands in high-stakes poker over and over, every single generation, forever, with no do-overs. Meanwhile, studies tracking predation attempts on adult octopuses by species like moray eels and reef sharks have found escape success is highly dependent on proximity to a known den. Octopuses caught more than a body length or two from shelter face dramatically higher mortality than those caught near home. It's the wildlife version of never answer the door for a stranger unless you're already standing next to the deadbolt. Every single trick we've covered so far, the camouflage, the ink, the mimicry, the shell armor, exists because the baseline odds are brutal and something had to make up the difference. Not every octopus is playing defense quietly. The blue-ringed octopus, small enough to fit in your palm, carries tetrodotoxin, one of the most potent neurotoxins found in nature, the same toxin found in pufferfish, in its saliva. When threatened, rather than fleeing or hiding, it does something almost show-offy. It flashes a pattern of vivid, iridescent blue rings across its body, pulsing, essentially advertising the danger instead of concealing it. This is what's called aposematicism, warning coloration, and it only works as a strategy if the toxin backing it up is real and consequences follow for whoever ignores the warning. Evolution essentially handed this animal a tiny neon sign reading, "I am absolutely not worth the trouble," and then made sure the sign wasn't bluffing. Somewhere out there is a predator that learned this lesson exactly once and never needed the lesson twice, assuming it survived long enough to learn anything at all. Here's where the rulebook gets thrown out entirely, because nature loves a good exception, and this one's a heartbreaker. Female octopuses are semiparous. They reproduce once, then die. After laying their eggs, a mother will guard the clutch obsessively for weeks or months depending on species and water temperature, cleaning them, aerating them with jets of water, fending off anything that approaches. During this period, she typically stops eating almost entirely. And here's the part that breaks the pattern we just spent this whole script building. Many of the camouflage and evasion behaviors we've covered get deprioritized. A brooding mother often won't abandon the eggs to flee a threat the way she would have before laying them. She becomes visibly weaker, less reactive, more vulnerable over the course of the vigil. And by the time the eggs hatch, in most species, she has died, her body having spent every remaining resource on this one uninterrupted act of guarding. All those defenses we just spent 7 parts admiring, every one of them exists in service of getting an individual octopus to exactly this point, once, so that the next generation gets a chance at needing them too. It's not a flaw in the system, it's the entire point of the system, and it's exactly as bittersweet as it sounds. Fast Fact 3. Researchers studying individual octopuses in controlled settings have found consistent behavioral differences between individuals when facing the same simulated threats. Some consistently bolder, quicker to investigate or confront a perceived risk. Others consistently more cautious, quicker to flee or hide. In other words, octopus personality is a documented, measurable thing. Somewhere on a reef right now, there is an octopus that is, scientifically speaking, kind of a coward, and another one that is, scientifically speaking, kind of an idiot about danger. Every office has one. Apparently every reef does too. I promised you honesty, so here's mine. The night I died, I wasn't hunting an octopus. I was trying to photograph one, a big, gorgeous day octopus doing exactly what you'd expect, holding dead still against a rock, betting everything on me not noticing it. And I didn't notice it for a solid minute, which is honestly a compliment to its skill and an insult to mine. When I finally did notice, I got greedy. I reached in for a better angle instead of backing off for a wider shot. My arm slid past a lip of coral I hadn't clocked, and by the time the octopus jetted off exactly the way we've discussed 40 times in this script, my arm was wedged, my breathing was climbing, and panic did the rest. The octopus's trick worked flawlessly. It's still out there somewhere, or its great-great-great-great-grandchildren are, having no idea it invented a ghost. I don't blame it. You wouldn't blame a lock for doing its job just because someone panicked trying to pick it. Myth 3. True or false? Myth. A bigger octopus is automatically a safer octopus. Verdict: false more often than you'd think. Why it's false. Larger body size means slower acceleration, harder time squeezing into small dens, and a more conspicuous silhouette against the reef, all while requiring more food, which means more time spent exposed while hunting. Some of the most effective escape artists documented are mid-sized or small species, precisely because they can fit into gaps a larger predator or even a larger octopus simply cannot follow into. Size helps with some threats and actively works against you with others. Nature doesn't hand out a single universal advantage. It hands out trade-offs and expects you to spend them wisely. So here's what I've got for you, collected over what has now been an embarrassingly long unpaid internship in ghost-based marine biology. 1. If you see what might be a camouflaged animal, assume it can see you long before you're sure you've seen it. The reaction time gap is not in your favor. 2. Never reach into a crevice you can't see the back of. Ask the guy who used to have working lungs how that turns out. 3. An octopus's stillness is not calm. It is a loaded decision waiting on your next move. 4. If you see a small octopus flashing bright blue rings, that is not a light show for your benefit. That is a legal disclaimer with teeth. 5. Respect the den. A midden estrels outside a hole means something lives there and it very much prefers to keep living there. 6. Don't confuse an ink cloud for a magic trick gone wrong. It's a decoy and a chemical smokescreen working together on purpose, aimed specifically at you. 7. If you're diving near a brooding female, give her room. She has already spent everything she has on the next generation, and she has nothing left to spend on you. 8. Every obvious rock, shell, or patch of algae on a reef deserves 1 extra second of suspicion. The math on how often that patch turns out to be alive is not in your favor either. 9. Octopuses are not shy. They are not simple. They are running a live-action escape room with props, disguises, chemical weapons, and improvisational acting, and the stakes are always real. 10. If you ever feel like you've outsmarted one, you almost certainly haven't. You've just arrived exactly where it wanted you to be. I spent a life underestimating an animal with no bones, no vocal cords, and a lifespan shorter than most car warranties, and it still got the better of me using nothing but chemistry, timing, and a very well-placed hole in some rock. I'd call that embarrassing, but honestly, at this point, I call it research. I'm going to go find another dark crevice to watch nothing happen in for the next 6 hours because apparently that's the job now, and there are worse ways to spend eternity. If you want more videos like this, subscribe.